So we learned last class में stresses 3 types, strain 3 types. Stresses का कौन सा stresses are there? 3 types of stresses क्या क्या है? Longitudinal stress, next बोलो, shear stress and volume stress. ऐसे ही second strain में क्या है? What are the 3 different types? Same type, right? Longitudinal strain, shear strain or volume strain. And what is the formula for longitudinal stress? Formula क्या है? याद है? बोलो कृष्णा.
Delta L by L.
Stress.
Force by area.
All stresses are force upon area only. Strain क्या है? आपको longitudinal strain formula is
Change in length by original length.
next volume strain.
Change in volume by
Delta V by V.
And ये वाला shear strain X by L.
Yeah,
Is placed by L or tan eta, right? X by L is called tan eta. Okay, that is called shear strain. Now we'll go for modulus of elasticity. On the video program, I can't see. Okay, now we'll go for the Hooke's law and modulus of elasticity. Hooke's law and modulus of elasticity. What is Hooke's law says from childhood onwards you're studying it? Hooke's law is within a proportionality limit, stress is directly proportional to strain. That is called Hooke's law. But up to proportionality limit तक only. Spring को मान लो, if you up to elastic limit तक आपको stress and strain are direct relation. Now if I remove this, stress is proportional to strain, right? When I remove proportionality, we'll get a constant, that is modulus of elasticity. E is called as modulus of elasticity, and therefore modulus of elasticity formula is what? Stress by strain. And stress का units are Newton per meter square. Delta strain का तो नहीं है. So Newton per meter square is the units of modulus of elasticity. Look. Okay, stress is proportional.
one second. Done.
हम लोग modulus of elasticity also we have 3 different types of modulus of elasticity. Same thing, okay? Now एक का we'll learn. So first one is Young's modulus of elasticity. We represent as Y. Y is the Young's modulus of elasticity. What is Young's modulus? It is defined as the ratio of the normal stress. Normal stress is nothing but longitudinal stress. Sometimes they'll call normal stress. Okay. So longitudinal stress by longitudinal strain is called as Young's modulus of elasticity. Similarly, bulk stress by bulk strain is nothing but bulk modulus of elasticity. Shear stress by shear strain is called as shear modulus of elasticity. Okay, we represent as Y, F by A by delta L by L. F by A by delta L by L. So if I cross multiply like this, multiply कैसे क्या होगा? FL by A delta L. So Y का formula है simply FL by A delta L. ऐसा लर्न करो. FL by delta L. A delta L. So longitudinal stress by longitudinal strain is called as Young's modulus of elasticity. See, modulus of elasticity is a constant value, right? Constant value रहेगा because stress is proportional to strain. उधर से आया ना ये modulus of elasticity. So y is constant value, but it depends on what? Y depends on what? Y depends on any parameter. See, y is equal to f L by a delta L, right? So किस पर depend होगा? Temperature पर depend होगा. It depends on temperature. Okay. Tell me, if I increase the temperature, what will happen to the Young's modulus of elasticity? If I increase the temperature, what will happen to the Young's modulus of elasticity? Well, constant varying. Anybody? If I increase the temperature, what will happen to the Young's modulus of elasticity?
Will increase.
Why?
So because the strain will increase with temperature.
No, it will decrease. It will decrease. Why? If you increase the temperature, the length of the conductor will increase. Delta L will increase. If delta L will increase, what will happen to the Y? It will decrease. So very important. As temperature increases, Y decreases. Okay, because elongation is increasing. Okay, ये भी आया JEE Mains में. So formula again ना FL by A delta L is the formula. FL by A delta L. तो वायर को elongate किया तो delta L is nothing but elongation, net elongation कितना है. Okay. And assignments क्या है? Newton per meter square only. Because strain का don't know units, right? Numerics करेंगे based on this. So इसमें JEE Mains थी. आपको JEE Mains में questions में ज़्यादा questions will be coming from Young's modulus. तो थोड़ा ज़्यादा questions करेंगे इसमें. Okay. करो एक question करो अब देगा. A truck is pulling a cart with a bridge by means of a steel cable. एक cable से pull कर रहा है. When the car just begins to move, the tension in the cable is this much, but the force is given to you. How much has the cable stretched? One delta L is identified. Young's modulus is given to you, right? So formula is y is equal to FL by A delta L. And find delta L. Calculate. Don't copy it somewhere. Try to calculate. Then check.
Sir, the 9.1 meters is the length, right? It's not the elongation.
Length only. Steel of cable that is 9.1 meters long below, no? Original length.
So will the elongation be the length plus radius?
Delta L is asking, not L है. Radius किधर है, length किधर है? एक wire है. So length L है. इसको elongate किया तो change in length only I'm asking. Change in length. Delta L is.
Oh, they are changing length. My bad.
Sir. Sir, 5.1 into 10 to the power minus 8.
Minus 8, huh?
Yes.
Wrong. 10 color wrong. 5.1 correct only, but 10 color wrong. Maybe units में आपको गलती होगा. Centimeters में दिया ना? You converted, huh?
Yeah, sir. So when you convert it, it will become into 10 power minus 4, right?
-2, right? हाँ, square किया था तो
Square, हाँ.
And यंग्स मॉडुलस का भी मल्टीप्लाई किया था. नीचे मल्टीप्लाई किया तो क्या आएगा टेल में? 10 power of 11 into 10 power of -4. How much?
So 10 power 11 will cancel with 890 may there's 1 0, it will cancel, so it will become 10 power 10 into 10 power minus 4, which is 10 power 6.
आराम से ऊपर लेके जाओ भाई, उधर कैंसिल करके इधर कैंसिल करके.
They wanted the answer in, sir, I got the answer in millimeters.
मीटर्स में बोलो.
Sir, in meters is very big.
Sir, I
Okay.
got 10 power minus 4.
0.000516.
10 power of -4 is answer. Yes. So 5.2 into 10 power of -4 is answer. नीचे में there is no, ऊपर में कुछ नहीं है.
Yeah, 10 power minus 4, I got it.
Yes. So मैं कैसा? नीचे में आपको 10 power of -4 is there, 10 power of 11 is there. So 10 power of 4 minus 11 is how much? Bottom में 10 power of 7, हाँ?
10 power of 7.
ऊपर गए तो 10 power of -7.
Sir, but then there's one 890 also in
And
the.
10 power -6. Then क्या होगा? Then, yeah.
And then 10 power minus 6. So we'll get 515 into 10 power minus 6. So if you take, it will become 5.1 into 10 power minus 8.
ठीक है, वो कैलकुलेशन देखो, मल्टीप्लाई कर, कैलकुलेटर मल्टीप्लाई करते हैं, इस आंसर 5.2
Sir, I'm sure this is right.
5.2 into 10 power of -4 meters. ओके, देखेंगे मे बी कैलकुलेटर में देखो, मतलब इन दोनों का आया है ना सेम आंसर. ओके चलो नेक्स्ट करो, विदाउट कॉपिंग करो, सिंसियरली करो. ओके, a bimetallic rod is there, brass and copper is there, length is 0. Copper has a length of 0.5 meters. Okay, length is 0.5 meters and rectangular cross section in shown figure. If the rod is subjected to compressive force, मैं compress करूँगा, ये rectangle है, तो इसका ये 1 है, 2 into 1 है, right? Because total 2, right? So it is 1, right? No. So this is 2. So width is 2, depth is 1. Okay, then the compressive of each metallic parts is how much? When I apply a force like this compressive force में, it's asking delta L is how much in दोनों में? दोनों का delta L is how much? Calculate करो.
So both of the brass and copper have same length and same force.
Same length and same force, yes. Copper. So delta L of each one we want.
So they didn't give radius.
Radius क्यों? Width
Area
is given, right? Width is 2 and depth is 1 centimeter. Because
So what is compression?
Compression is pushing.
So delta L.
एक rod को fix कर दिया, compression में delta L बैठा है. Delta L in each based on the material it will compress, right? So we want delta L for each one. You use calculator also, no problem. So to
So width is 2 and height is 2. So the area will be 4, right?
see width is 2, height ये पूरा 2 है, right? So मुझे ये brass का बोलते 1 centimeter हो, right?
Oh. So the brass area and copper area will be the same only.
Oh
then.
yes, yeah.
Sir,
Okay. Tell.
sir, 1.3 into 10 power minus 1 and
Yeah.
1.1 into 10 power minus 1.
1.1 into 10 power minus 1. Okay, 10 power minus 3 आ रहा है actually. No problem. उसमें 2-3 decimals लिया होगा. So 1.389 into 10 power minus 3. First one.
Sir, I use calculator. 1 second. Sir, there's something after that, sir. It's okay.
Yeah, चलते रहो. Like decimal में ना calculator use करो. ये थोड़ा बड़ा है, but JEE में questions देने वाला. That time without calculator. थोड़ा on the video.
Sir, will you get 1.38 into 10 power minus 4
Oh yes. Good.
for brass?
Copper is.
Copper, 1 second.
Yeah.
Eleven into So will you get copper as 2.2 into 10 power minus 4?
Copper is 1.136 in 10 power minus 3. FL by A delta L, right? AY. हाँ प्रणव कितना है?
Sir, I got this thing. Sir, I got 2.2 into 10 power minus 4.
See, F is how much? 5 into 10 power of 4, right?
So find 10 power of 4 into 0.5 divided by 11 into 10 power 10 into 2 into 10. Oh, into 2. Oh my god, sorry, wait, I forgot into 2. 1 second. Yeah, sir, 1.136 into 10 power minus.
Okay, next.
1.136 into 10 power minus 4 only, no?
10 power of minus 3. 1.136 into 10 power of minus 3 meters. Okay. Next one. A solid steel cylinder standing vertical on the floor. The cylinder length is this much, radius is given. Object is placed on the top of the cylinder. एक object रखा उसके ऊपर. Compressive, it compresses by amount. Delta L value also given. What force is applied by the cylinder? Force only asking.
So is it 5.7 into 10 power 7 or 10 power minus 7?
Which one?
The compressors.
10 power minus 7.
Sir,
Yeah.
4.2 into 10 power 4.
Yes.
Sir, I got 42.
4200 आएगा. One. Right? 4200.
Oh, yeah, so 4.2 into 10 power 4.
4.2 into 10 power 4 newtons is answer.
So area will be pi r square only, right?
Pi r square. Then next
So I want to get, sir, I got 4,200.
yes, correct. Next one.
Oh.
एक steel wire है, length है 1.5 meters and steel wire है 1.5 meters and 4 kg block is there and 1 meter का brass wire है and 6 kg is there. Mass is there. It's telling compute the elongation of the steel wire and brass wire. But delta L, each one we have defined. Brass wires and steel wire का each one we have defined. And when you're calculating steel wire, what is the force? Tell me. mg, right? mg is which one will take? Steel wire का delta L find करने के लिए what is the force we will take? Tell me. We'll take 4G या 6G या आप दोनों मिलके ऐड करेगा स्टील वायर में. स्टील वायर के ऊपर कौन सा फोर्स एक्ट हो रहा है? इट इज दोनों ऐड करो 10G.
mg plus mg.
दोनों ऐड करने का 10G. But when you calculate for a brass wire, only 6G force is acting. Okay, he's asking delta L in each case. Can I get it? The given diameter, your converted radius, one is steel and other is brass. Come on. It is calculated. So
Oh.
दो वायर्स है स्टील वायर एंड ब्रास वायर. इन दोनों में डेल्टा एल इज आस्किंग. ऐसे अरेंज किया तो व्हाट इज डेल्टा एल?
Sir, I got the delta L of steel as 1.5 into 10 power minus 4. Yeah, I just calculated. I'm doing the other one.
करो कैलकुलेट करो.
So force on steel will be 60, right?
Force on steel is 100 G.
Oh.
Because steel को कौन कौन पुल कर रहा है? ये मास भी राइट. So 100 G. Like 10 G, right? 10 G is 100.
So what's the area?
Area बोलो आपको. Diameter is given, right?
Okay.
Circular.
Sir, I got the brass as 1.3 into 10 power minus 4.
Yes.
Sir, I got the steel as 1.83 into 10 power 18.
No. Delta L can do FL by AY. A is pi r square. Y1 F1 FL is 100, right? Into L1. L1 is 1.5. Let's calculate and solve. ठीक है, कैलकुलेट करो, मेजर समझ में आया वो देखेंगे. नेक्स्ट.
Wait, sir. Sir, 4.2 into 10 power minus 4 is brass, and steel is 4.8 into 10 power minus 4.
Steel is 1.49 10 power of minus 4. 1.49 10 power of minus 4. And brass is 1.49 into 10 power of minus 4. That is steel. Brass is 1.3 into 10 power of minus 4. Because इसमें steel में force how much you used?
Steel is 100.
Brass में?
Brass is 60.
खत्म. चेक किया होगा. देखो. चलो. कैलकुलेशन देखो. नेक्स्ट. अब JEE में क्वेश्चन स्टार्ट करो. हो देखते हो सिंसियर करके बोलो. Young's modulus of A and B is given. Areas are given. Same load is applying for both wires. Amount of elongation of the wires A and B is the ratio. Del L ratios.
Still, length will also be the same.
He has given what? While area of projection, same amount of load is applied in both wires, so same elongation. Assume length of the wire A और B are same बोल के दिया ना.
Okay, sir.
So same amount of load means force.
Yes.
Sir, I got 12 is to
Sir,
1.
1 is to 12 is to 1.
Sir, 1 second.
देखो.
Yeah, 12 is to 1.
Yeah, 12 is answer. Next.
You get 4 into 10 power minus 3.
देखो.
Sir, I got 4 into 10 power minus 11.
Minus 11. Okay. Up.
So minus 3 only.
Yes, 10 power minus 3 answer. 4 into 10 power minus 3. Why here area is given 10 power minus 4 and y is also 10 power of 10. ना? So whatever नहीं आएगा 10 power of minus 4 है bottom में, right?
So
10 power minus 4, 10 power of 10, right? Thanks for this. So it is minus 3 आएगा. How should?
yes, sir.
Yes.
So 1:1.
देखो.
Sir, even I got minus 1.
So 1 second. Yeah, 1 second, 1 second. Last step. 1 second. So I can use calculator, right?
Yeah. इधर कैलकुलेट करने का जेई में क्वेश्चंस भी कर करेगा.
Yeah, 1:1.
Yes, understand. Yes. नेक्स्ट वन. ज्यादा क्वेश्चंस कर रहे हैं इसमें जेई मेंस में बिकॉज यंग्स मॉडल्स में आपको ज्यादा क्वेश्चंस आए.
So what is delta L?
Force required to stretch the steel to double the length when the area of cross section is 1 centimeters and Young's modulus is 6 months. So delta L के क्या देते हैं? आपको थिंक क्या रहेगा? डबल द लेंथ बोल के बोला ना. So changing length will be how much? Original length है और डबल द लेंथ
So
बना
2
देगा.
into 10 power 7.
Yes, correct. So we have it. Initial length is L. The force required to stretch the wire to double its length. So delta L is how much?
2 delta L.
No, delta L is L only. 12 minus L. So कितना चेंज हुआ टोटली 12 minus L. This is the
Yeah, delta L is L only, yeah.
solve.
Yeah, so you get it 2 into 10 plus 7.
Yes, 200%. So force is asking, right? Force is y into area. Transfer. Okay, so next. Okay, force constant and stiffness of wire के बारे में learn करेंगे. Force constant and stiffness of wire. Okay, तो इसमें क्या है आपको वायर के साथ we can combine with the spring. Wire के साथ we can combine with the spring. Okay, so we'll see that one. A force required to produce a unit elongation in the wire is called force constant. So कितना force लगेगा to produce unit elongation produce करने के लिए we call it as force constant. Force constant of stiffness of the wire we are calculating. Like spring का कैसे है stiffness, right? K value depends on stiffness, right? ये भी ऐसे force constant we are calculating. वो use करने से क्या होगा आपको certain times में wire को we can assume as spring and we can calculate. And याद है series and parallel में spring का formula क्या होगा when connected series में K1 K2
1 by K equivalent equal to 1 by K1 plus 1 by K2.
parallel में add करना पड़ेगा. वो यूज करके we can make simpler easier sometimes. Okay. Okay.
Yeah.
तो देखो analogy of the rod and spring. Rod को you can assume as spring. उसका constant है spring constant है K and उसका force apply किया delta L change हुआ. देखो इसमें we know that force we are calculating in this. Normally for this formula y is equal to FL by A delta L. So from this F is equal to how much? Y A delta by A by L times delta L. This is a force we are calculating. And spring force का formula क्या है? F equal to K times of delta X nothing but delta L होंगे. If I compare, what is K value? Spring constant का K का formula है Y A by L. मतलब suppose you want to convert the rod to the spring. The term spring constant K value का क्या use करेंगे? Y A by L use किया तो you can use as a you can convert as a spring easily. Okay, Y A by L. They taught how this one? Prisha, school में spring का conversion they taught how? Chapter done right?
Sir, I don't remember.
Very important. Y A by L use correct. So when always without spring conversion also you can do, but sometimes certain times में calculation बड़ा हो जाएगा. So better sometimes they'll ask also spring constant का corresponding कितना बोलते हैं pi A by L use करके we have to calculate.
Sir, they taught this.
Is equivalent spring constant बोलते हैं. Equivalent spring constant. So whenever they're more than टू स्प्रिंग सीरीज पैरेलल, k के जगह पे k इक्वलेंट यूज करना पड़ेगा, k f इक्वल टू k इक्वलेंट टाइम्स ऑफ डेल्टा l एंड k इक्वल यू नो k1 k2 सेपरेटली फाइंड करो एंड व्हाट आर द सीरीज है तो कंबाइन करो, पहले तो उसका कॉम्बिनेशन यूज करके सॉल्व करने का, राइट। तो फॉर्मूला आ गया YA/L यूज करना पड़ेगा, YA/L। तो देखो सिस्टम ऑफ रॉड्स, आई टोल्ड यू टू रॉड्स आर देयर, they connected, देखो this is one wire is there, this one wire is there, so they are in series, right? So I can combine with the springs also, k1 k2 I can find a1 y1 by l, ay by l, right, a2 y2 by l, and then I can find k equivalent by using this formula k1 k2 by k1 plus a2. so you k equivalent use करें तो then जो भी पूछेगा वो कर सकते हैं ना, k equivalent times delta l, suppose delta l पूछ रहे तो you can use f by k equivalent, ऐसा यूज करके you can solve. तो रॉड को वी आर कन्वर्टिंग इनटू स्प्रिंग, उस टाइम में k का फॉर्मूला a y by l यूज करना पड़ेगा और y a by l.
So this is general like for all system of rods, k equivalent is k1 k2 by k1 plus k2.
Yes, because k1 is always a by y1 by a, उसका यूज करें ना, so all for all rods, this is valid. Done. अगर पैरेलल है तो सिंपली k1 plus k2 करें.
Yeah.
थोड़ा लिखो अच्छे से, इधर उधर ढूंढने से क्या मिलेगा आपको, टेक्स्ट बुक में आपका साथ ही रहेगा, टेक्स्ट बुक में नीटली लिखो पूरा ऐसे. इफ यू स्टार्टेड सीइंग द टेक्स्ट बुक वगैरह में इधर उधर में लास्ट में कंफ्यूज हो जाएगा, अच्छे से एक जगह में नोट्स लिखो, ये लास्ट में बहुत हेल्पफुल होगा आपको एक जगह में. तो नोट्स टाइम में नोट्स बनाओ अच्छे से. टेक्स्ट बुक इसलिए टेक्स्ट बुक्स वगैरह बंद करो एंड ट्राई टू कॉन्सेंट्रेट 1 आवर क्लास का कॉन्सेंट्रेट करो, लिखो जो बोल रहे हो लिख के, देन आप 23 आवर्स रहेगा आपके साथ ही टेक्स्ट बुक रहेगा, देन बैठो या उसके साथ ही करो, बैठो क्या करेगा. ओके चलो, नो सेम वे देखो कॉम्बिनेशन में ऐसा है तो आपको ऐसा करना पड़ेगा नॉर्मली, इसका सीरीज आने के बाद पैरेलल करने का लिखने की जरूरत नहीं है, क्वेश्चन करेंगे. करो एक क्वेश्चन. सी ये क्वेश्चन नॉर्मल भी कर सकते हैं बट आपको स्प्रिंग्स का यूज करके करो, स्प्रिंग का यूज करके करो. एक कॉपर है, कॉपर है, ब्रास है, उसका लेंथ ऑफ गिवन एंड अप्लाइंग ए कंप्रेसिव फोर्स, फाइंड द अमाउंट द लेंथ ऑफ द स्टैक डिक्रीजेस, फाइनली टोटल लेंथ कितना डिक्रीज होगा. नॉर्मली क्या करेगा, नॉर्मल मेथड से क्या करेगा, नॉर्मली डेल्टा एल, इसका डेल्टा एल सेपरेटली विल कैलकुलेट एंड विल फाइंड, राइट. बट विदाउट यूजिंग द कांसेप्ट ऑफ दैट वन, स्प्रिंग का यूज करके सॉल्व करो, डेल्टा एल फॉर ईच वन फाइंड करो. देन सीरीज है पैरेलल, टू रॉड्स, then in series, right, two rods in series, so try to find k equivalent and delta l find karo. So f is equal to k equivalent times of delta l is equal to f by k equivalent. delta l find करने का use calculator and tell the answers. use by spring concept, spring का concept use करके solve करो. k1 you know already, this is k1, k1 is a y by l and k2 is a y by l, a copper का, a brass का. After getting k1 series है ना, तो k equal क्या आएगा, you can use this one also, k1 k2 by k1 plus k2, because 1 by k equal to 1 by k1 plus 1 by k2 is nothing but आप restful कहते हैं ये आएगा, use कर. and finally substitute after finding k equivalent and force तो मालूम है ना, force 9,000 न्यूटन दिया, use कर, use calculator proper.
Sir, over here the length and the radius will be the same. No, how will the length be the 6.28 and 3.14?
separate length दिया ना, but radius दिया तो same है, radius वगैरह same है दोनों को.
No, sir, I think they gave radius to find area.
यूज करो, pi r square यूज करके solve. समझ में आया? K1 separate find करो, K2 separately K equivalent find करो. Is absolute here, we get the total examination, right?
So you have to find the total length, right? Like you have to find the length of copper, length of glass, and add both.
ऐसा सोचेगा आप, इंडिविजुअल किया तो ऐसे करना पड़ेगा, बट ऐसा किया तो you'll get K equivalent आ गया ना, अपने आप आ जाएगा टोटल लेंथ पे.
Oh,
If you go like a string, आपको डायरेक्ट आ जाएगा. If you go for normal rods का separate separate ऐड करना पड़ेगा.
sir, I by mistakenly did individual and I got answer as 0.04.
ठीक है, अब आया समझ. चलो, so these are the Young's modulus of elasticity वाला हो गया. Next we have to go for a bulk modulus of elasticity. Bulk modulus of elasticity. Now tell me, bulk modulus में कौन सा tell me? Bulk modulus में which ratio? Which stress by which strain? Volume stress by volume strain. Okay. Bulk modulus को B से रिटर्न करेंगे और K से, both are same. Okay. तो लिखो, defined as the ratio of volume stress by volume strain is called bulk modulus of elasticity. And देखो एक बॉल है, बड़ा बॉल है, पानी में डिप करने से उसका वॉल्यूम गेट चेंज. दैट वॉल्यूम स्ट्रेस बाय वॉल्यूम स्ट्रेन इज कॉल्ड एज bulk modulus of elasticity. F by A by delta V by delta V, and you know minus आएगा ना, स्ट्रेन में बटा ना delta V. Okay. So and force upon area को प्रेशर बोलते हैं, delta P बोलते हैं. So this is the formula. So K का formula is minus delta P by delta V by V. Is it Prisha?
Yes, sir.
Yeah. On the delta V by this is delta V. So bulk stress का bulk modulus का formula is volume stress by volume strain. F by A by minus delta V by V. And bulk में सभी में होगा ना, सभी all states of matter में होगा, solid liquid gases में bulk modulus will happen. Then
Yes, sir.
अब जो नोट्स लिख रहे हैं that only will help you in the next because
Yeah.
सेकेंड ईयर में इतना स्मॉल नहीं है, वो भी बड़ा बड़ा दे दो टाइम. अभी जो भी कर रहे हैं शॉर्ट नोट्स बनाओ अच्छे से, फिनिश कर. लास्ट में आपको देख जस्ट गो थ्रू द मॉडल्स एंड देन स्टार्ट डूइंग द क्वेश्चन. ओके, compressibility. Compressibility is nothing but reciprocal of bulk modulus को we call as compressibility. So sometimes they'll tell to find compressibility means आपको bulk modulus find करो, उसका reciprocal करो, will get the compressibility. So bulk modulus का फॉर्मूला क्या है? डेल्टा P by minus डेल्टा V by V. Okay. न्यूमेरिकल्स करने समय माइनस निकल दो, नो प्रॉब्लम. But delta P by delta V by V is the formula for bulk modulus of elasticity. Okay. Bulk modulus का देखो उसमें एक प्रेशर के साथ रिलेटेड करेगा. We already know pressure में mechanical properties of fluids में we study delta P's. How much? As we go depth inside rho GH1. Or you use कर सकते. They can link with the pressure and this one. Okay. तो क्वेश्चन करो.
Sir,
हाँ.
sir, can you, sir, in the previous question, what was F?
Before F का value. क्वेश्चन क्या है इसमें?
Sir, it was
Similar.
that copper and brass.
Okay. So that is 4.64 into 10 to the minus 2.
So the answer or F?
Okay. I'm telling it. Oh, no. Wait. This one, no?
Yes, sir.
F is 9,000.
Okay, sir.
Answer to relation. Okay. Now देखो. To what depth below the surface of the sea should a rubber ball be taken to decrease the volume by 0.01%? कितना डेप्थ में, मतलब कितना h we have to find so that the volume becomes 0.1%. Take density is given, bulk modulus is given, acceleration to gravity is given. करो कौन? क्या देखते
Yeah.
हो? To what depth below the surface you have to go so that the volume get decreased by 0.1%. मतलब what is 0.1%? Delta V by V into 100 is given as 0.1. Into 100 करने से ये परसेंटेज के वैल्यू डालने का. Again don't put by 100 वगैरह. So from this delta V by V is how much? So 1 by 100, 1 by 1000, 10 power of minus 8. Okay. But bulk model is also given. 9 into K, right? KRB same. 9 into 10 power of 8. No find. So find depth. How much depth means h we have to find. Right? And we know as we go depth in.
So should I take minus delta V by V as negative, or is it okay if it's positive only?
No problem. Positive also because value is given it. So minus निकाल दो.
So I got 9 to 10 power 7.
Wrong. Units में mistake करोगे. So bulk modulus का.
Sir, is it 90?
Yes, all that we can do. Delta P by delta V by V. So he compared with delta as we go inside, my pressure will be rho gh, right? Chilling pressure will be rho gh. By delta V by V is 10 to the minus 3. I just go. Rho is given, G is given, H is given. So
90.
yes, 90 something.
So I want to get 90.
Yes, 90. Next. Okay. Similar to approximate depth of the ocean is H is given now. Compressibility is given, not bulk. Compressibility is given. Density is given. What fraction compression of water will be obtained at the bottom of the ocean? What fraction of compression means? What do you define? Simply delta V by V. What fraction of water is obtained at the bottom of the ocean? So same, he has given compressibility. From compressibility, say you can find bulk modulus, right? So use that.
So fractional compression means delta V by V.
Yes, fraction compression is delta V.
So 1.2 into 10 to the power minus 2.
देखें. इसका क्वेश्चन स्टार्ट कर लो पूरा, पी वैक्यूज करना पूरा इसका. तो यूज करो कितना.
So 1 second.
So 1.4 in 10 power minus 2.
1.4 हाँ.
Yeah.
देखेंगे. वन पॉइंट टू फॉर्मूला क्या है? डेल्टा V by V. So delta, and this is nothing but 1 by C only. So delta V by V is how much from this? Delta P into C. Right? C will cost from there. No, sorry. So delta P is rho GH, right? Into C. Everything is given. Substitute करने से आपको आंसर आएगा 1.2.
1.2. Yeah, 1.2.
Minus 2 is answer.